share my screen. Okay. Just tell me, is it visible? Hello. Each screen is visible?
No, sir. Sir, presentation. Yes, sir. Now it is visible.
Disconnect.
Yes, sir. Visible.
Okay, now I think it's visible. Okay. So now we're going to start with the stack. Okay, so this stack is basic. Basically, already have. Okay, so stack of part particularly. So this is stack goes like that. Okay, so a stack data structure stores and applies the item in the last in first order. Okay, so it will be what we say first. So these are the plates. Okay, so this example we have taken. Okay, so we have plates which are kept one above other. Okay, so we're only able to remove the topmost plate. Okay, so it's not possible to remove any bottom plate in between. Okay, so we are only able to remove the topmost plate. Okay, so this topmost plate we'll calling as a top end. Okay, so the insertion and deletion, insertion and removal only happen from the top end. Okay, so that this is the terminology of the stack. Okay, so that we have seen. Okay, so for with respect to stack, we must we have a terminology like that, LIFO. Okay, so what is LIFO? That is last in first out. Okay, so who comes last, it is going to out first. Okay, so for that purpose, stack is called as LIFO. That is last in first out. Okay, and in queue, suppose we are standing in the queue for suppose bank account opening. Okay, so any queue we have. Okay, so suppose this is a row, we are entering more here. Okay, and we are leaving this queue from over here. Okay, so now this is my counter in front of. Okay, so this is my counter, I can say, in front of. Okay, so it is called as an FIFO. Okay, so FIFO means what? It is first in first out. Okay, so that is called the FIFO terminology. Okay, so first in first out. Okay, so there is an entry point. Okay, so where the elements are inserted into this particular part. Okay, so elements inserted over here. Okay, so there is one entry point from here and there is one exit from here. Okay, so that is called as an first in. Okay, so this is called as a queue. Okay, so the implementation will be same. You can say in queue we have 2 pointers. Okay, so in stand we have a top point.
Sir, थोड़ा lag होता है sir. Sir. तुमचा आवाज नीट नाही येते म्हणजे.
Okay, now just tell me whether it is okay. येते का आवाज आता नीट?
Yes, sir. Yes,
okay, so I will share again the screen. Okay, so I just again revise that point. Okay, now it's audible clearly.
Yes, sir.
Yes, sir.
So we have seen, so in stack you enter from one end and there is only one end from you remove. Okay, so for that purpose we are saying last in Okay, last is going to enter. Okay, so that we have, so that is first out. Okay, last in first out. Okay, so last element which is entered inside the stack, so that will be only removed. Okay, so you cannot remove this 4, you cannot remove this 3 2 1 anyhow. Okay, so this is the terminology of the stack, we can say. But in queue terminology, okay, so this is my queue. Suppose we are standing in a bank, okay, bank line for account opening. Okay, so there is one entry for this queue. Okay, so and there is one exit for this queue. Okay, so what happens, the student or the person who comes first, okay, so suppose this is my queue. Okay, the student or person which comes first, okay, so that is first in. Okay, so the person who comes first, okay, so that is we can call first in. Okay, and that person will be first out. Okay, so this is called as a FIFO terminology. Getting the difference between stack and queue? Hello? Stack is called as last in first out, and this queue is called as first in first out. Is it clear? Hello?
Yes,
Can
sir.
we move forward?
Yes, sir.
Yes, sir.
So now stack queues and dequeues. Okay, so we have, okay, so stack is the last in first out data structure. Okay, the items are removed from a stack in the reverse order. Okay, in the way as it is inserted. Queue is the first in first out data structures. Items are removed from the queue in the same order as they were inserted. Okay, and dequeue is the double-ended queue. Items can be inserted and removed at either end. Okay, so both end will be okay for working with the dequeue. Okay, so likewise you are in a bus. Okay, suppose PMT, so you can come from any of the door. There are 2 doors. Okay, and you can exit from any of the door. Okay, so likewise we have a dequeue, but queue and dequeue will be there in the next unit. Okay, so that we have. Okay, so we have an array implementation of the stack. Okay, so to implement a stack, items are inserted and removed at the same end. That is the only terminology. Okay, so we have an efficient array implementation. It requires that the top of the stack to be towards the center of the array and not fixed at one end. Okay, so that we have. To use an array to implement a stack, you need both the array itself and means the first thing we need, that is array we need, okay, to implement of this particular stack. Okay, and the integer value, so that we can put means which location is at the top. Okay, so that integer variable will require, that will refer to the top element of it. Okay, so how many elements are in the stack, so that we also get from the top. Okay, so suppose this is my array. Okay, suppose this is my array we have. Okay, so in that array, so I will insert first element 2 over here. So now top is pointing over here. Okay, so again there is another element comes over here, so that is 3. Okay, so top is pointing over here. Okay, so another element comes at 5, so again top is pointing over here. Likewise it is getting to be working. Okay, so that we have. If anyone told you, okay, how many elements are there in a stack, how we can calculate total number of elements present in stack?
Value of top.
Yes. Okay, so there will be 3, that is top plus 1. So we can say
Yes,
top
sir.
plus
Value
1.
of top plus 1. Yes.
Yes, so top will be at 2, so top plus 1 will be at that place. Okay, so that we have. Okay, so there are 2 main methods in the stack which are available, that is push and pop. Okay, so already yesterday we have discussed these 2 methods. Okay, so that we can say okay. So we have these particular things, so pushing and popping. So this is my stack. Okay, so now top is pointing to 3. Okay, so or you can say the total elements will be 3 plus 1, that is 4. Okay, if the bottom of the stack is the location 0, then the empty stack is represented top minus 1 and your count will be equal to 0. Okay, so that you can mention. To add the elements in array, so already I told you, okay, you can set the top as 0 or top as minus 1. Okay, if the top is set to 0, so then you will make first top plus plus and then array of top equal to element. Okay, so that we can make. Okay, so increment the top and store the element into stack of top, or you can store the element in stack of count and then increment count. Okay, both way will be possible. Okay, so that you can work with this terminology. So better way not to confuse with 2 variables, that is count and top. Okay, so the terminology you can keep. Okay, so that you can make top as 0 or top as minus 1. Okay, so it depends on you. Okay, so if top is made as minus 1, so while insertion, so you just make top plus plus. Okay, so top plus plus you have to make. Okay, and you have to make stack of top. Okay, so I will make s of t. Okay, Okay, so to insert the element, so that will be the terminology s of t, okay, is equal to value. Okay, so that we can make. Okay, otherwise if you make the top as 0, so then you will make s of t will is equal to value. Okay, so the element will be placed at the current location, that is top. Okay, so s of t is equal to value, we can say. Okay, and afterwards you will make t plus plus. Getting? So these are the two ways by which you are insert the element into the stack. Getting?
Yes, sir.
Okay, so this particular operation we'll call it the push operation. Okay, and to remove the element, either you can make again for this terminology. Okay, so if I say this is the terminology, so what I will do, I will just print s of t and I will make t minus minus. Okay, so that we can have like this. Okay, so if top is pointing to this next element, so what we have to do, we have to make it minus minus first, and I have to print the element. Okay, and if top is pointing over here, so I have to print the element and then I will make minus minus. So it is again where it is pointing. Okay, so on the basis of you will work. Okay, so get the element from the stack top and decrement the top. Okay, again decrement the count and get the element stack count. Okay, so these two are the things we can perform actually. Okay. Okay, so the next thing we have after popping. Okay, so we'll have this particular thing. Okay, so suppose now in previous you have 44 in place. Okay, so after popping, the top will be shifted over here. Okay, and count will be 3. Okay, so when you pop an element, do you just leave the deleted element sitting in the array? So better way, it depends. Actually, you can make it 0. Okay, otherwise you can keep it as it is. But it's basically you must make with some numbers. Okay. Okay, if this is an array of primitives, okay, if you are programming C++, then doing anything more is just a waste of time. Okay, so okay, unnecessarily you can avoid this. Okay, so not to reset it with any of the number, because we are not able to move above the top. Okay, so top is the topmost element. Okay, so we are not anyhow with the terminology, we will not able to reach to this 44. Okay, so just you can shift the top below. Okay. So if you are programming in Java and if you are linked list like structures, okay, so we have to delete the element. Okay, so that we already discussed into the linked list implementation. Okay, so that we have. Okay, so the next thing that okay, sharing a space. Okay, of course the bottom of the stack could be at the end of other end. Okay, so that we can have. Okay, so there can be a 2 stack in between. Okay, so you can take one array. Okay. So in that one array, you can prepare 2 stacks also. Okay, one stack will start from this end. Okay, so like this, and one stack will start from this end to save the space. Okay, so that also you can work. Okay, because suppose you have declared a stack of 100. Okay, so and if there are only 10 elements, okay, in this stack, only 10 elements in this stack. So in that case, what we have so 90 elements space will be wasted. Okay, and if you are working with the array, so this is very huge amount of space we are wasting. Okay, so it's better way to start one stack from this end. Okay, start another stack from this end. Okay, so you just yourself keep in mind. Okay, so what is the top index? Okay, so here you just make top minus minus, and here you just make top plus plus. Getting how to utilize the space in case of array. Hello? Yes or no? Hello? Getting?
Yes, sir.
Okay, so you can have multiple stacks, not only 2. You can take more stack also. Okay, but only the thing is that you must remember, now in our normal case 0 is our bottom that we know. Okay, so if we reach to 3, so they will know that there are 4 elements. Okay, so but in this case we'll have the topmost element 8. Okay, and we have a negative pointer. Okay, so if it is 5, so we'll know that there will be 4 elements in that. Okay, and if in case suppose you have started with 2 in case, okay, so and you are approaching this end, okay, and we are reached to 4. Okay, so we know that there will be 2 elements only. Okay, so likewise you can have multiple stacks in a single array. Okay, so this is an example that is top, that is stack top will be over here, that is 2, and here will be 6. Okay, so this is one negative end and this is positive end, so that we can mention. Okay, so error checking, there are 2 stack error that can occur. Okay, so we'll have 2 errors. Okay, so we'll have an underflow. Okay, trying to pop an empty stack. Okay, so this is my stack, okay, so of an array which have no element, okay, and if we are going to pop the element, if we perform the pop the operation on that empty stack, so that will call it as an error, which is an underflow error, okay. Overflow error, I can say that, okay, if you are trying to push into an already full stack, okay, so this is my stack, okay, all the elements in place, okay, so that are placed in over here, okay, all the elements are placed, okay, so then that stack will call it as the full stack. Getting? So these two errors which we have. Yes. Yes, underflow and overflow error. Okay, so yesterday also we have discussed is empty and is full. Okay, so that we have to check before inserting the elements into the stack. Okay, underflow means what? If there is no element, then and we are popping the element, so this is called as an underflow. And overflow means what? There are already stack is full and we are popping the element. Okay, so that we are pushing the element, so that is called as an overflow. Getting? So these two types of errors will be there if we are implementing stack with the help of arrays. Okay, overflow will not happen and throw an exception. So before popping out, okay, you just check whether the stack is empty. Okay, means if the top is pointing to -1 in one terminology, or it's 0, whatever your implementation. If it is means 0 or -1, so in that case you have to throw an exception. Stack is empty. Okay, so you cannot pop the element. Okay, so if you don't catch it yourself, Java, if it is in Java implementation, so there will be an error array index out of bound. Otherwise, in our implementation also, it will give an error if you are going to access -1 element. Okay, so it will not work. Okay, so you could create your own more informative exception. Okay, so for overflow, you could do same thing. Okay, so you can check whether that size of the array is reached. Okay, so if the size of array is reached, so you have to check is full. Okay, so is empty and is full. These two conditions we have to check. Okay, so basically this is up to array implementation. So any doubt in this? Till implementation of the stack with the use of array. Yes, clear?
Yes, sir. Yes, sir.
Okay. So just a point of just discussion. Okay. So I will give you 10 minutes. Okay. So anyone just okay, you just try to implement this concept. Okay, stack with the use of array. Okay. So what you have to do? Okay, just I will give a hint. Okay, so you just declare an array. Okay, yesterday we have seen the implementation of this stack using linked list. Okay, so today we just try. You just declare an array, name as stack or array with some size. Okay, and you just have 4 functions to be implemented. Okay, so one function is push. Okay, so one function we can say push. Okay, another function is pop. Okay, thereafter function is empty. Okay, we'll have is empty as a function. Is empty. Okay, and finally is full. Okay, so these are the 4 functions you need to implement with the use of array for the stack implementation. So will it fine? So can you do that in 10 minutes? Can you try?